Hello everyone, in this video we're gonna continue the topic 9.5. We're gonna learn how to find the magnitudes of displacement. First, we need to find the displacement components, delta S and delta Y, by using the fundamental theorem of calculus, integral from A to B of f prime of S ds is equal to f of B minus f of A. So we have s of b minus s of a equals integral from a to b of s prime of t dt, right? And I'm going to name this one as delta s. Similarly, I have delta y equal this guy, right? And the magnitude is going to be absolute value of delta r. It's going to be square root of delta s squared plus delta y squared, right? Now let's move on to example number 4. An object moves along a curve in the xy plane with precision s of t and y of t at time t greater than or equal to 0, where ds over dt equals 2 plus sine t squared. So this guy actually s prime of t, right? And this guy actually y prime of t. Alright, now question A. At what time t is the speed of the object 3 units per second? Alright, you have the velocity vector. It's gonna be s prime of t, y prime of t, right? And it's gonna be 2 plus sine of t squared e to the 1 minus t. So we have the speed is gonna be magnitude of the velocity vector, right? And it's gonna be square root of 2 plus sine t squared, right? All together square plus e to the 1 minus t all together square. And we're gonna let this one equals 3, right? So we're gonna square both sides. Add graphs, input this function, press enter. Now input the second function, hit tab, hit 9, press enter. Alright, we need to find the first intersection right here. So I'm gonna restrict the domain. Go to menu, window setting right here. As minimum, I just put 0. Maximum, I just put 5. Y minimum, I just put 0. And maximum, I just put like 10. Press OK. It's right here. Alright. I'm gonna press menu, number 6, number 4. Go to the left, go to the right, the answer is right here. 0.214. Question B. Find the acceleration vector at time t equals 1. So you know that as equals d squared s over dt squared, right? So it's gonna be derivative of 2 plus sine of t squared dt, right? 2t cosine of t squared, right? Now y is gonna be d squared of y over dt squared, right? So it's gonna be d of e to the 1 minus t over dt, right? So it's gonna be negative e to the 1 minus t, right? Now we need to find as at t equals 1, right? So it's gonna be 2 times 1 cosine of 1, right? So it could be 2 cosine of 1. Now a sub y at t equals 1. It's going to be negative e to the 0. It's going to be negative 1. So final answer is going to be 2 cosine of 1, comma, negative 1, right? Now question C. Find the total distance traveled by the object over the time interval 0 to 3. So you know that the distance is given by the formula interval from 0 to 3 square root of s prime of t altogether square plus y prime of t altogether square, right? dt. So you're going to go to home screen, hit calculate. Now I'm going to store the function s prime of t as m of s. Press Ctrl the button right here, press enter. Now I'm going to store the function y prime of t as n of t, right? Alright, now I'm going to press the button right here, input the interval right here, from 0 to 3. Press square root. Input s prime of t square plus y prime of t square. Press Ctrl, enter. It's going to be 7.493. Now let's move on to question D. Find the magnitude of the displacement of the object over this interval, right? So we need to calculate delta S is going to be interval from 0 to 3 of S prime of t dt, right? Delta y equals interval from 0 to 3 of y prime of t dt. So the magnitude of the displacement square root of this guy right here, interval from 0 to 3 s prime of t dt altogether square plus interval from 0 to 3 of y prime of t dt altogether square, right? Now I'm going to bring up the calculator. I'm going to input the square root. Now hit the button right here, input the interval from 0 to 3 of m of s right here, right? Now I'm going to do exactly the same thing for n of s, right? Then I'm going to press Ctrl, enter. The answer is 7.249. And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals, they take us higher. The night's young and it's just begun as she puts her hand in mine.